Hello, everybody. My name is Ivan Drobish, and I'm the host of today's JavaScript Competency Center week. So actually, this is the week number 5 because previously we already had 4 of them, and you can check them out on our YouTube channel and rewatch if you're interested. So actually, this is our traditional JavaScript Competency Center week, and we prepared a lot of different interesting topics with the senior and interesting speakers. And let me probably introduce the agenda of current week. So tomorrow we'll have talk with Nazari and Vladlen about system design, introduction, interview, case, design, URL, shortener. If you're interested in system design, feel free to rewatch that. On 15th of May, we'll have talk about LLRT, Lightning Fast AWS JavaScript runtime with the Pavel and Denis. On 16th of May, we'll have interesting talk about AI. Yeah, of course, we have a hype about AI as well. And the name of the talk will be I Don't Need Any AI. So feel free, if you're interested, feel free to subscribe and watch it. And the last talk will be about the Vue Transitions API, the end of SPA. So again, very hype and catchy title. If you're interested, feel free to join and see this talk with Vitaly. And actually, I haven't mentioned today's talk that we'll have. The talk will be about Angular. And the talk will be about exploring the power of Angular signals, a game changer in Angular development. How do you think is RxJS on its way out? Yeah, let's find out it with Sergey Gultaev.
Hello, everyone. My name is Sergey, and I work as a
Yeah,
lead software engineer at EPAM.
Yeah, thank you very much, Sergey. Before we begin, I would like to tell to everybody that Sergey will be able to answer all your questions if you have them. So feel free to leave them in comments in YouTube or via community channel. And at the end, I will read them out all, and Sergey will answer them. And Sergey will be able to choose the most interesting or maybe the most challenging one, and the person who asked this question will be rewarded by special gift from us. So I think that's it from my side. I'm passing my word to Sergey. Sergey, let's explore the power of Angular signals.
Yeah, let's do that. So, today we'll be talking about Angular signals. This is a new edition of Angular from the last year, and it became stable with the release of version 17 this fall. So, let's begin with the simple question. What is a signal? In simple words, it's just a function that holds a state. When you call it, you will receive the current state. What's special about it is that Angular knows when the value changes, so when you just use it in the template, it will update automatically as soon as you change the value. To change the value, we have two methods, set and update. Set is very simple, it just accepts a value and that's it. Update, on the other hand, and accept a callback, and it will give you the previous value and count the new one. Also, we have as read-only method that allow you to create a read-only signal if you want to share your state, but you don't want your consuming code to change it accidentally. Along with the signals we received computed, it's a great addition which allows us to create a read-only signal, and it will evaluate something based on your signals. Maybe you can use even some other properties and return a value. What's special about it is that it's lazy evaluated, which means that until you read the value, it won't be executed. Also, it's memoized, which means that you can multiple times use it in the template, you can read it in the code, but it will execute only once. And it dynamically tracks the dependencies, which means that, for example, in the example we have on the line 19, unauthorized. If it's true, it will return and it will not read the user. It will not know that we need this specific signal at this moment of the time. However, as soon as the unauthorized changes, it will pass down to the user. It will return the combined string, but now it will track both signals, unauthorized and user. So whenever some of them changes, it will automatically reevaluate and update the template. So you don't need to pass an array of the signals, etc. It's all done for you automatically by Angular. Another great addition to the signals is an effect. An effect is just a function that will be executed whenever the signal changes. Indeed, it will execute the first time that you have created it, and then whenever the value changes, it will re-execute. It's very useful if you want to synchronize the state, if you want to maybe do some side effects, you may want to log something. Also, optionally, you can use the onCleanup function to provide some teardown logic. For example, you could get rid of the created timers, etc. Also, we have a destroy method, which is returned by the reference, and we can call it if you want to manually dispose of the effect by some reason. If you don't do it, as soon as your component gets destroyed, an effect will be destroyed as well. When we're talking about signals, one of the important things to remember is that they are immutable. This means that you cannot push, for example, into an array. You cannot change an object because Angular will not know about it. You have to pass a new reference to the value. And in order to reduce the amount of recomputations, we can pass an equal function. It's a different one from the previous. This means that we can spare some time, some resources on re-evaluating or re-rendering and something. For example, we can use a lodash is equal function to compare if the new array is different from the old one. Another use case is Untracked. Untracked is a very interesting function because it allows us to exclude anything inside of the call from the tracking dependencies. Since our signals are functions, we can just pass the signal reference inside of the Untracked, and it will just return the value of the signal but not track it. Or we could pass a callback and again execute some code. Some internals of Angular use this specific function in order not to trigger some undesired side effects. When we're talking about signals, it's worth to remember that they are different from RxJS. For example, if we create a signal with the initial value is 0, then we create an effect which just has a constant log, because for the sake of the example, we want to only print out all the values that the signal has. And the first value will be 0 when the component gets rendered. And after next render, we'll execute a callback and we'll change the signal's value 3 times in a row. And as we can see, it will only log the last one. And it's because Angular waits for signal to become stable before propagating the events. And here comes like the most important difference between RxJS and signals. Signals do not emit all the values. They emit the latest one from when they become stable. Also, we need to remember that effects are tied to the change detection. So if you detach your component, your effects will no longer run unless you manually run change detection in it. Also, with the version 17, we received inputs. Those are signals. They work the same way from the outside as the old decorator inputs, but the key difference is that they return us a signal that we can work with. And as you remember, we have a computed, which means that we can finally derive state from inputs without using the setters, without getters, without trying to overcome some race conditions, etc. Also, we can tell that the input is required by calling the required method. We can pass all the same stuff as we used to pass to the decorator inputs, such as alias, transform functions. But you have to remember that right now, if you specify a generic type for the required input and you do not specify the second generic type, you will get an error as on the screens on the left bottom corner, because TypeScript does not infer types partially. It will think that the type is undefined, it will complain, so you'll have to throw just unknown and it will work. Model inputs is different from the signal inputs in a way that models, they are two-way bindable and they are mutable, which means that you can use a set method to change the model value. On the signal input, you cannot do it because it's a read-only. Also, one key addition with the model inputs is that as soon as you create this kind of input, you automatically support the two-way binding. You do not need to create the output anymore. For example, on the line 3, we have simple input. So the parent would have to use the square brackets, pass the signal simple input value, and it could also listen to events separately by using the parentheses and simple input change, or you could use the banana in the box syntax and pass the value there. Also, an interesting thing with model inputs is that when they came, the compiler changed, and now we can bind to the two-way bindings signals and plain values, and it works both ways with the old definitions and the new ones. So on the side, you can see that we have any child, and it has just a value, and it's a model, which means that it automatically set up for us an input and an output. And we have an old child, which has a value of type string and value changed explicitly defined as an event emitter. On the right side, we can see that their declarations are identical, and we can use the signal binding in two-way bindings even for all child, and it works just fine. Great addition also to the Angular was the queries. No longer we need any query list because everything is just signal. If you have just one view child, it will just give you a signal of this specific child. If you have view children, it will give you a signal of array. So you work in a unified way. You always know what you will receive. You can work with it in effects. You can work with it in computed. So much simpler. Angular team does realize the importance of coexisting with the current code base and that RxJS needs to interoperate with the signals. And for this purpose, we have two observable and two signal methods, which indeed converts a signal to an observable and an observable to signal respectively. Also, we have functions such as output to observable and output from observable. Those are for the new outputs. Output technically is not a signal, but it was unified in order to have an identical and cohesive code base where everything is now functions and we almost have no decorators anymore. And finally, we have a way to define configurations that are changeable at runtime. We can react on them way simpler than we could ever do it before. We just create a signal. Signal can be stored anywhere. It's not scoped to just components or services. You can store basically it everywhere and pass it as a reference, and then you can update it. In the code where you need to use the signal, it's just a function call. You don't need to subscribe. You don't need to unsubscribe. You don't need to keep in memory all those memory leaks because everything is handled for you by the Angular. Also, signals are not only improving our life in terms of how the code looks, but also how it works. For example, if we have an observable on the line 15, get user, it's just an HTTP client get observable. And on the line 4 and 5, we use it and subscribe to it with a sync pipe. And as many of you know, it will create two calls because basically each time an observable is subscribed to, it will re-execute unless we do a lot of modifications, we do multicast, etc. But with the signal, we just wrap it into a to-signal function and it will be just one call because everything will happen inside of that function and we can call it as many times as we want. We can also call it from the components code synchronously and you will get the value. Also, signals are great when working with on-push change detection strategy. One of the common problems that newcomers to Angular have is that when they change something, they do not see it updated on the screen. However, in this specific case, we have a signal. So when we update the signal's value on the line 14, even although it's inside of the subscribe function, it is still getting the re-render because Angular knows that you used this signal inside of the template and it knows that the signal has changed. Therefore, it will re-render it for you. Going forward, we're expecting to land the version 18 of Angular this May, and it will also bring a so-called hybrid change detection, which means that not only it will tell Angular to check this specific component for changes, but also if you ran the change from outside the Angular zones, it will also schedule a change detection for you, so even less troubles. When talking about RxJS and signals, we still need to work with them. For example, on the line 8, I defined a page input. So I want to receive a page number and I want to get the data based on current page. For these purposes, we would use some techniques. Before, we would have to create some, for example, behavior subject. Then we would have to change it using either ng on changes or setter on the input in order to change the value. Then we would use some switch map. Now we can use just a computed async. It's provided by the library called ng extension. You can follow to the documentation by scanning the QR code. And it's very simple. We just pass down the callback. This callback returns an observable, which will be converted later to an T signal. And this observable consumes a signal's value. Internally, computed async is an effect. And all effects, as we remember, track up its dependencies. This means that when the page changes, it will also re-execute the request. You might be wondering here, why am I using ng on init? Why am I passing an injector? What's happening here? Well, the reason is quite simple. First of all, we have a required input. This means that if we try to read the value of the input before it was set, NGL will throw an error at us at runtime. So we have to move to the ng on init for this. Then, when we move to ng on init, NGL will throw at us another error that the effect is run outside of the injection context. And this is a very important part here when we're talking about we're talking about effects, because in order to do all this magic for us, NGL needs to know when is, for example, a component or a service that gets destroyed, and it's called an injection context. Basically, injection context, you can think of it as something where you can call the inject function from. And as you can see, we can call it from the function declaration, from the property declaration, we can call it from the constructor, but we cannot call it from the engine init. So we have to first inject the injector and pass it as an option to the computed async, and it will work. Going forward, we expect the non-components, which means that we will have no longer have the ng zones, we'll have way less bundle size. The change detection model will be way simpler. You'll have to just remember that when the signal changes, the template gets updated. That's it. You don't need to remember about events, about monkey passion, stuff such as expression has changed after it has been checked. I think it's one of the most favorite of all Angular developers. Also, we're expecting formats powered by the signals. And the Angular development team confirmed that they're working on it. Another great addition of the recent weeks was that there was a TC39 proposal to add signals to the platform, and it's reached stage 1, which means that signals are actually being considered by the corporation to adopt it into the JavaScript. It was created by the authors of more than 13 frameworks. So there have been a lot of work done there, and it's very exciting because if it gets adopted, there also mentions that we might actually get in future some primitives in web components which would declaratively bind their template to the signal, which means that basically you will be able to create web components and do declarative updates. And we expect to land the hybrid change detection, as I mentioned previously. Basically, it's first steps towards zoneless. The team is still working on it in order to prepare, to check if everything is working correctly, because as you can guess, it's a very huge change. And we got to the most disturbing question of all developers. Will signals replace RxJS? No. As you have guessed, is because basically they solve different problems. RxJS is about events. It's about doing some combinations, mutations of those events, etc. Signals is just about state and notifying the consumers when the state changes, even skipping maybe some changes if it happens too quickly. And what key takeaways here? Signals are awesome. If you haven't updated yet, I highly recommend you do so because you can use them already. They are production ready. Unfortunately, right now, effects in inputs and outputs, they're still in the developer's preview, although I don't expect them to change too much, but you can already use the signals on computer. They're totally fine. Also, we need to remember that signals are different from observables, so you may want to use them all in different scenarios. We cannot say that you have always to use the signals or always use RxJS. It very depends on the case. And indeed, RxJS and signals are friends. And Gotium is ensuring that they are saying so by providing us those handy functions for interoperability. And now let's get to the Q&A session. While we are on it, I highly recommend to subscribe to the folks on X. This is Angular development team. They are very active. They post a lot of stuff. They also respond a lot. So you can ask them questions. You can get some useful insights from them.
Thank you very much, Sergey. Thank you for the presentation, and I'd like just to remind you guys that you are able to ask any question you want. Feel free to do it in the comments in YouTube or your community. And since I'm not an expert in Angular development, I have only one question. Why have you chosen Angular instead of React? So everyone knows that React is better. So why Angular has been chosen?
So you chose violence, right?
I'm just asking.
Well, for me, it was pretty much simple. Back at the time when I was starting just my front-end career and I was learning, I first started with AngularJS. Then I saw React and I realized that no, I don't want to do AngularJS because it was terrible with all those directives and stuff and scope. Then I discovered that, okay, there is Angular 4. And that's when I fell in love because I see a great framework that provides you with a lot of tools. It provides you with a separation of concerns because I have separate my HTML, JavaScript, CSS. I don't like when it's in the same file because it's hard to read. And another thing, I still remember how I tried to migrate like a React router from version 3 to version 4. I didn't manage to do it. So
I'd like just to
abandoned it.
remind that there was AngularJS and Angular version 2 or 3.
Yeah, the 3 was skipped.
Yeah, so that's why probably like our kind of bad example of migration of React router. It's not something worth to mention when you're Angular developer, but yeah, there was. Okay, yeah, it was, of course, it was like joking question. So for me, I was chosen. I chose React because it was just like something that I had project with, so I didn't have actually a lot of options, and I just hadn't tried Angular. Okay, and I don't see any questions. And before we finish, I would like just to remind you guys about our future events. So tomorrow we'll have talk with Nazari and Vladlen about system design. So if you're interested in system design, how it goes, how the interview process looks like in different modern companies, feel free to check it. The next one is talk with the Pavel and Denis, Lightning Fast AWS JavaScript runtime. Yeah, feel free to join and check it out. The next talk that will be on Thursday about AI. So everyone knows that there is an AI and all this hype about AI, but the talk is about that you probably don't need any AI. And the last one on the Friday that we'll have will be with Vitaly. The talk will be about Vue Transitions API and with the question, the end of SPA. If you're interested, feel free to join. Yeah, check it out. So subscribe to the channel, likes, comments. Yeah, I think that's it. Thank you very much, Sergey. It was really interesting. I hope, because I'm not, I didn't understand anything here. And thank you guys for watching, and have a good day. See you.
Thank you, guys. See you.